Hello my dear champions, welcome back to our channel Deeksha Karnataka. I'm here with another class in Masterstroke. The chapter is Inverse Trigonometric Function. As you know, the first one was Relation and Function. This is ITF. ITF is also pretty easy but plays a very big role. First of all, getting those 2 marks in KCET. The weightage is 2 marks from this chapter, and also in the continuity and differentiability or integrals, the questions are used from the concept of ITF, right? So knowing the graphs, knowing the domain range, knowing the operations performed in properties of ITF is very crucial. And of course it's a very easy chapter, so let's not lose marks on the basis of these concepts. Okay, so our class guarantee will not lose mark because of ITF. That is the reason why we are learning this particular session. Any question that comes anywhere which is having the application of ITF, I'll have that sorted by learning the concept and solving problems in this particular class. Let's start quickly. I know your time is very important, so without wasting time, let's start with the introduction. Now, so first thing is the concept. The word here is inverse. Let's try to crack everything with the help of this word only, inverse. So the inverse of any function exists if the function fx is what? Function fx is, sir, bijective in nature. When a given function is bijective in nature, then only I can say that the function is invertible in nature. Bijective means that function should be 1 1 and onto. The function should be 1 1 and onto. Means if I have a function 1 1 onto, it's called as bijective function, and that is an invertible function. Okay, so inverse of trigonometric function is having that meaning only. Means those trigonometric function which can be invertible, we find the inverse of that and we get the inverse trigonometric function. But we have also learned that all the trigonometric functions are periodic in nature. Example, the simplest one, sin x. Check here, sine goes like this. Am I right? Yes. So if you keep continuing till the plus infinity, and on this side as well, you'll get what? You'll get the function periodic over the period of 2 pi. Okay, sir. So it repeats every 2 pi. Check here. This is 0 and this is 2 pi. Okay. Then if I try to draw a straight line through it, you'll get more than one intersection. If you draw a straight line parallel to x-axis, you'll get more than one intersection. It means it is not 1 1 and also not onto. Then what we do over here? No, it's not going to be a case of your bijective. To create that, we create something called as creating a section or creating a restriction. Creating a restriction in domain. So what we do is, right now domain of y equal to sin x, this is the curve of y equal to sin x. So this curve domain is what? All real numbers from minus infinity to plus infinity. So what we do here is create a restriction in the domain. When I do that, I'll end up with a function which is going to be invertible in nature. Can you see the restriction right now? This point is minus pi by 2 to this is what? Pi by 2. Let's draw this restriction over here once again. Basically, zoom this part in, this here. Check here. The graph now changes to this. The graph now changes to this. Okay, I can do better. 1 second, guys. This is very important. This is very important. This is the graph now. This is the graph now. Okay, where the right hand side, the domain ends at pi by 2, and on this side the domain is starting from minus pi by 2. The boundaries in y is what? This is 1 and this is minus 1. Now if you check, the given function is invertible in nature. Now the given function is invertible in nature, it has become 1 1. So by providing some type of restriction in all the different functions, we try to make into what? We try to make it into an invertible function, and later we find the inverse. What happens when we find the inverse? Of course, the domain and range interchanges. So the value of domain of the original function will become the range of the inverse function, and the value of range of original function will become the domain of the inverse function. That much we know. But this slide agenda was to understand how can a periodic function in trigonometry become invertible and we find the inverse. Clear? Moving on. Again, this is what? This is your sin x. with the domain as what? The domain as minus pi by 2 to pi by 2, and the range is what? The range is minus 1 to 1. The range is minus 1 to 1. Now, inverse of a function, as I already mentioned, we know that it is a function. If the function is 1, 1 and on 2, then it is an invertible function. So if the function starts from fx to y, where x is the domain and y is the codomain, then I can write a function gy to x, where y will be domain and x will be the codomain. And what happens here is the function will be called invertible. Okay, so example, as I said, to check here, this is a function. Now we'll not write the original domain that we are writing for sin x. We'll write the restricted domain. We'll write the restricted domain. So domain will become what? Check, guys. Domain will be over here minus pi by 2 to pi by 2. What is the range? The range will be, check here, the range will be minus 1 to 1. Minus 1 to 1. Whereas in this ITF, if I write here, the function is written like this: y equal to sine inverse of x, sine inverse of x, and what happens? The domain becomes this one, minus 1 to 1, and the range is of course minus pi by 2 to pi by 2. This is your range. So basic idea from here is output of a inverse trigonometric function will be always an angle. Output, that range value, the y value, will always be an angle in the case of inverse trigonometric function. Is it clear, guys? Yes. Of course, we'll have more situations like this in all the 6 ITFs. For example, for cos inverse, tan inverse, sec inverse, cosec inverse, and cot inverse. We'll see all of that, no problem. But right now, that is it. Same thing written over here. Domain and range interchanges. Okay, they interchange each other. So once we find this value, we interchange the domain and range. Okay, and this is what it becomes, something called as PVB, principal value branch. So what you see, this one, the output, this particular value is called as principal value branch. Okay, this is called as principal value branch for particular function y equal to sine inverse of x. Okay, come on, because usually when the question is not mentioning anything, we write the answer in terms of this PVB only, principal value branch only. Okay, moving on. Whenever no branch of an inverse trigonometric function is given, we mean the principal value branch of the function. The value of the inverse trigonometric function which lies in the range of principal value branch is called as principal value of ITF. Okay, means the corresponding value of minus 1 to 1. Okay, yes. Next, for all of you who are writing KCET, have you all taken ABHYAS? Have you not? If you have not taken, you are missing out, because hundreds and thousands of students have already started practicing questions in ABHYAS. How? They are part of KC90. They have taken this test series separately also. So they have started solving the mock test. How many mocks are there? 31 is paid, 4 is free. Total of 35 mock tests are there in subjects physics, chemistry, maths, biology. Okay, they have started practicing all together. Okay, you can see in my life, few students came, they were asking, sir, we were talking about ABHYAS. So many of them are already practicing mocks, they are improving. Somebody was getting 135 and so on, basically. Okay, so the more and more mocks you solve, you get to have an idea of how you are improving in every topic, every subject. Okay, so very important to take the test right now and start giving more and more mocks, because as your boards get closer, you will not have time to practice for KCET. Okay, this is the time to do it, and their total of 35 mock tests includes both part test and PT and FLT, both is there. Part test and full length test, both are there. So for somebody who is having time, they only can access and attempt all the papers. If not, then you will miss out. Okay, and all of this is available at 1499. Take the test right now and start solving as many mocks as possible if you want to seriously be over here. Look at these toppers: 171, 443, 693, 934, 2427, and many such good ranks was there. All the students did use ABHYAS KCET test series. This is recommendation by your seniors, your toppers of previous year batch. Okay, so don't forget, if you are writing this examination this year 2026 KCET, you got to take ABHYAS, the best test series out there, to help you all get a outstanding result and a very good college with your dream of seat. Okay, now, so as you all know, if you have studied from me in the past also, I love to teach with the help of graphs. Okay, so that's why it's very important, even though I can just show the graph to you and move on, but what I'm going to do, I'll not do that. I'll not just show the graph and move on. I'll draw the graph for all of you. I'm going to take the graph and draw it for all of you and then only move on. And we'll also talk about the nature of the graphs. Sine x, sine inverse of x, how do you draw it? So first you're going to draw this curve, this particular curve. What is this? This is the curve of sine x after the restriction. After the restriction, okay? This point is minus pi by 2 and this point is pi by 2. Now how do you get inverse of this? By simply taking the mirror image of this curve across this line y equal to x. Y equal to x line. What is this line called as? Y equal to x line. This curve is what? Sine x. Image about this will be what, sir? Will be this beta. Please check. You'll take image, you'll get like this. Okay, and over here you'll get like this. Excuse me, I can do better. Yeah. So your graph, if I have to write the result, it look like this. This is your curve. It is not perfect in this case because of I've taken 3 graphs in the same graph, like 3 different curves in the same graph. But if you check the plane over here, this is the representation of y equal to sine inverse of x. Check here. This value was what, beta? This was 1 and this was minus 1. It reverses. Okay, now you're gonna feed the value to what? Minus 1 and go all the way till 1. The output will be what? Minus pi by 2 and this is going to be pi by 2. Check here. This is your graph of y equal to sine inverse of x. Check. So maximum value is pi by 2, minimum value is minus pi by 2. Okay, so what is the maximum value? Pi by 2. What is the minimum value? Minus pi by 2. Output I'm talking about, not the input. Output. Okay, odd function, of course sine is an odd function. What is the meaning of this? It means sine inverse of minus x will be what? Minus sine inverse of x. Nature increasing means if you increase x value, fx also increases. It means sine inverse of x also increases. Okay, check here. If I move from left to right in the x-axis, left to right, what is happening to the graph? It is going up, up, up. It's increasing in nature, right? It is going up, up, up. Sine inverse of x increases. Basically what it means is, if I have x2 value more than x1 beta, if I have x2 value more than x1, then f of x2 will be more than f of x1, which implies sine inverse of x2 will be more than sine inverse of x1. This is the meaning of increasing function. For all x2 more than x1, sine inverse will also be more than sine inverse of x2 will be more than sine inverse of x1. So the nature is very clear, increasing in nature, odd function, maximum value is pi by 2, minimum value is minus pi by 2. I think first graph is clear to all of you. How to draw it and what are the results? Can I write domain and range also for all of you? Domain, range. Domain will be what? Minus 1 to 1. Range will be what? Minus pi by 2 to pi by 2. Next curve. Next curve will be cos x, cos inverse of x. Okay. This, can you see the nature first? In the graph only I'll draw, of course. Nature will be first one, decreasing. Decreasing in nature. How can I say that? Take any value x2 more than x1. Take any value x2 more than x1. Cos inverse of x2 will be less than cos inverse of x1. cos inverse of x1. So basically if you apply cos inverse on x2 x1 on the same way, the inequality reverses. This was greater than, this is less than. I'll show you with example also. I can show you with example also. 1 second. Check here. If I take this point to be, let's say x2, this point to be x1, this is this value over here represents your, check here, this represents cos inverse of x1, and this represents, sorry, cos inverse of x2, which is more. So of course cos inverse of x1 is higher than cos inverse of x2. So cos inverse of x1 is more than cos inverse of x2. So this is a decreasing function. Odd, even, neither. Odd, even, answer is neither. Max is pi, min is 0. Max is pi, min is 0. Okay, this is your nature of this. What's the meaning of odd and even, neither? This means that cos inverse of minus x is pi minus cos inverse of x. This is the formula. We're going to use this in the property. Very useful formula. Very, very useful formula. Okay, now let's draw. The last thing is to, okay, I didn't tell you that, but I can write it over here. I'll write it over here after drawing it. Okay, the domain and range. Check this out. So cos x, when I'm going for cos x, I'll start from here and go till here. This point is pi, this value is 1, and this value is minus 1. What did I say? To draw, what is this curve for? This is the curve for cos x. To draw the curve of cos inverse, you will take this line. What is this line called as? Y equal to x curve. Okay, straight line, mirror image. So you'll get this result, right? Correct? No? Is not looking proper. 1 second, guys. I can do better. I'll make it look much better. Yeah. This is the curve that comes over here, and it goes like this. No, excuse me. Up, right? Up. Yeah. Something like this. Correct. Check, this red part is the image of this part. Okay, this red part is the image of this part, and this red part, smaller one, is the image of this other smaller one. Okay, so if I draw the graph individually, like separately, I get the curve like this. Okay, now this is not straight line, my bad. This is not straight line, that's how it looks. I'll change this. Yes. Yeah, better, little bit better. Okay, this is little bit better. This value will be what? Input is -1, output is +1, excuse me, +1, and this is going to be 0. This will be what? Pi. This will be what? Pi. So my domain for y equal to cos inverse of x, my domain is what? Same, -1 to 1, and my range is what? 0 to pi. Everything is explained over here. Please check dear. Yes, this represents your cos inverse. Now don't worry about like values, because over here the x-axis is angle and y-axis is what? Values. Okay, over here it is just opposite. Y-axis is the angle and x-axis is the values. Okay, because of course it will be invertible. No, it will be invertible in nature. Yeah. So clear, guys? Everything is clear about cos inverse of x. Moving on, tan inverse of x. Okay, this nature, sir. First one, increasing or not? Of course, increasing, sir. Check here. X increases, y goes up. X increases, y goes up. So function is increasing in nature. Second one, odd or not? Odd function. This also is odd function. Sine inverse, tan inverse, and cosec inverse is a odd function. Maxima will not exist. There's no maxima over here because it will never reach pi by 2. even though you might feel that it is, so pi by 2 is the maximum value. It never touches that. It never actually have a closed interval on that. Okay, so max min does not exist. Max and min DNE does not exist. What is the meaning of odd? Odd means that tan inverse of minus x is minus tan inverse of x. What about increasing function? That we can observe over here, of course. If I take two values, let's say this value and this value, x1, x2, what is this going to represent? Tan inverse of x1, and this will be what? x2. Tan inverse of x2. Check carefully. Check carefully. For all x2 which is more than x1, tan inverse of x2 will also be more than tan inverse of x1. Will also be more than tan inverse of x1. Is it clear or not? Please check. Yes. I'm trying my best to give you all the understanding that you need for solving any questions, not only in this chapter but also in calculus. Okay, so yes, you know that, right? How important is increasing decreasing function in your AOD and of course in integration wherever you are dealing it with. Clear? Drawing the graph. Drawing the graph. Drawing the graph. One second, I can do better. I can do better, sir. First draw this, y equal to x. Okay. This is y equal to x line and this is your curve. One second, just little bit patience, little bit patient. Okay, sir, something like this and like this. This is what? Tan x. I want to get what? Tan inverse. What is this value going to be? I hope you know this. This is going to be minus pi by 2. This will be what? Pi by 2. Pi by 2. Clear? Now if you go to the mirror image, you can see that clearly over here. This is the curve. Image of this part is this part and this part image is like this. Yes or no? This upper green part, this is the mirror image. This lower green part, this is the mirror image. If I draw the curve, of course, what we saw earlier, it goes like this. This is the curve. It's not very smooth, I understand that, but I hope you get the point. Okay, this line over here is called as minus pi by 2 and this line over here is called as plus pi by 2. Plus pi by 2. What is the domain going to be? Negative to positive infinity, means all real number. So for y equal to tan inverse of x, domain is all real number. And what is the range? Minus pi by 2 to pi by 2, but open brackets. But open brackets. Is it clear? Please check. Done? Done? Any problem? Not at all. Moving on. Now cot inverse of x. Over here you can see the graph. Okay, this function will be again not even. So odd also not there, even also not there. Decreasing function. Decreasing function. Check here. Increase, value will decrease, so decreasing function. And what else? Did I miss something? Yeah. There's no maximum because it's not going to have any higher or lower value. Okay, no max min. So this is there. Domain and range you can find out from here. Domain is what? All real. Range is what? 0 to pi. Both open. Cosecant inverse, same way. Here also, this function is what? Decreasing in nature. Check here. This is, if you go towards right till this point, decreasing. Here also decreasing. So cosecant inverse, decreasing in nature. Okay, and this is the odd function. This is the odd function. Okay, so this is odd function. Okay, odd function, decreasing in nature. Okay, decreasing in nature. What else? Yeah, maxima will be pi by 2, minima will be minus pi by 2. That's the maxima minima. Max is pi by 2, minima is minus pi by 2. Max over here, minimum over here. Next, this is minima. Anything else? Second verse. Again, max is pi, minima is 0. Okay, and this is going to be increasing function. Check here. If you go like this, increases, here also increases. So, increasing function. No, this again will be not odd, not even. Odd, no, and even also, no. This is what increasing function I already mentioned. Yeah. Maximize. So max is pi, min is 0, and I hope you know this. Sec inverse of minus x will be what? Pi minus sec inverse of x. They write it over here as well. Cosec inverse. This is odd function. Cosec inverse of, one second guys. Cosec inverse of minus x is given by minus cosec inverse of x. It's odd function. Okay. Cot inverse, again the same rule applies, neither odd nor even. Cot inverse of minus x is given by pi minus cot inverse of x. Yes, here also this we have the property. Yeah. Check this out. So all is mentioned and written in the same table as well. All the 6 ratios, the respective domain and range. Okay. As I mentioned, second verse, lower limit is 0, upper limit is pi. In cot inverse, there is no lower limit and upper limit. Cot inverse, there is no lower limit and upper limit. As I mentioned, no max, no min. Okay. Here, cosec inverse, it is pi by 2 minus pi by 2. You can check here. Cosec inverse. This is the boundaries. Clear, guys. So remember these very important direct questions might come on this table and also applicable in your lot of calculus questions. Moving on, the graph summary is also there. Check here. Domain, range, all is listed with the graph also. Okay, so download this notes. How would you download it? I hope you've all joined the channel, right? Subscribe our channel right now, Deeksha Karnataka, and keep the notification of the classes always on. If you don't, you'll miss out on the lectures and then you'll regret it later, and you don't have any later right now. This is the last time that you revise and learn everything properly. If not, again you'll come back and say, sir, I missed this, I did not do this, sir, what to do in the last minute, sir, and they'll have no answers, just to say, just to tell you something that will make you feel good, but it will not be truth. Okay, so try to think and work hard right now. Download the class notes, PDF will be there in the WhatsApp channel. Join, link for that is given in the description of this video. Every class you miss, you're losing marks, as simple as that. If you're learning from me, every class you miss, you're losing marks. So attend all the sessions. Now solving some examples. Principal solution of cot inverse of minus 1 by root 3 will be what? What is this? Pi minus cot inverse of 1 by root 3. This value is pi by 3. Answer is 2 pi by 3. So option A is correct. Makes sense? Next one. Domain of function cos inverse of 2x minus 1. Domain they're asking. For cos inverse, this value ranges from where to where? Minus 1 to 1. Move 1 on this side, so minus 1 plus 1, 2x, 1 plus 1, 0, 2x, 2. Divide by 2 on both sides. Divide and divide, you get 0 by 2 is 0. You get x, you get 1. 0 to 1 closed. 0 to 1 closed is option number A again. Clear? 0 to 1 closed, option number A again. The value of cos of tan inverse 3 by 4. Very simple question. Take this value as alpha. Tan inverse of 3 by 4 is alpha. Tan alpha is 3 by 4. This is alpha, this is 3, this is 4, and this is 5. How come 5, sir? Pythagorean triplet, we know that. What are they asking? Cos of alpha. What are they asking? Cos of alpha. I've taken this as alpha, know the angle. So cos of alpha, base upon hypotenuse. So 4 upon 5. Problem? No. 4 upon 5 is the right answer. X plus 1 by x equals to 2. Then the principal value of tan inverse of x is what? Take here. X square plus 1 by x is 2. X square plus 1 equal to 2x. X square plus 1 square minus 2x is 0. X minus 1 the whole square is 0. X value is 1. Sine inverse of x will become what? Sine inverse of 1 will be pi by 2 c. Why not 3 pi by 2? It is not negative. Sine 3 pi by 2 is minus 1, not plus 1. Answer is C. Domain of sine inverse of GIF of x is what? Check here. This will be always from where to where? Minus 1 to 1. Because if I take sine inverse of y ranges from where to where? Minus 1 to 1. Domain is minus 1 to 1. So same question concept I have applied over here. Okay. Now, so if I want to make this free, think about it. On this side, for what value of x, listen to me very carefully, for what value of x, listen to me, for what value of x will this upper limit be only 1, not more than that? Of course 2, sir, less than 2. Put here 1.999, 1.99999, put here 2, answer is 2. So for everything which is smaller than 2, if you put in this from 1 to 2, you'll get the answer as 1. So x is less than 2 means it will, if x is less than 2, this will be true. This right hand side part will be true. Yes, super. Now on this side, for what value of x this will be always more than minus 1? Minus 1. If you go beyond that, right here, minus 1.5. What is the answer for this? Minus 2. Think about it. Minus 0.99. What is the answer going to be? Minus 1. Minus 1. So basically you cannot go beyond minus 1 on the number line. This is minus 1. You cannot come on this area. You can have to be in this area only. Hence, minus 1 to 2 is the answer. So minus 1 is closed and 2 is open. Answer is option B. Good? Problem? Not at all. No problem, right? Doubt if you have, comment section is there. Put all your concerns over there. Next, domain of fx, sine inverse of x, tan inverse of x, sec inverse of x. Domain of fx. First you're going to find values of these first. Values of these. And then we'll try to identify. So domain of first one, minus 1 to 1, sir. Domain of this one, this to this, sir. Domain of this one, check here, all real except for open bracket, not close brackets. Minus 1 to 1. I'll write them on number line and show you. Number line, first one, check this out, negative and positive infinity. First one is this one, sir. It means all of it. This is your tan inverse. Next one is minus 1 to 1, sir. This is the answer. Including both. Including both. Correct. The last one. The last one. Last one is, sir, minus 1 is inclusive and then this way. 1 is inclusive and then this way. Now if you take the intersection, these two if you take, you'll get this only as intersection. Now if you take these two, you'll get only these two as intersection. So answer will be minus 1 and 1. Whatever bracket, curly bracket, which shows elements. Answer is only two value, minus 1 and 1. It is not minus 1 to 1. It is minus 1 and 1. That's why I've written here the bracket is mid bracket, minus 1 and 1, which shows the elemental form. So elemental form means minus 1 and 1 are the two elements. Answer will be option B. Correct. Now this is the elemental bracket. Option B. Very good question. So if it is having, let's say, g of x, g1x, g1x, g2x, g3x, however many number of function is there, take the domain of all the functions and take the intersection of all the domains. Answer will be that only. Next. Properties of ITF. If you operate sine inverse on sine, answer will be x if x is between the principal value branch. Same for cos inverse of cos, tan inverse of tan, cot inverse of cot, and so on. Even if you operate otherwise, if you write cos of cos inverse, let's say if I write here this sine of sine inverse of x, what is the answer? X only, provided this x lies from where to where? -1 to 1. In this case, x is where? For sine x. That's why x is an angle. So that's why we written here belongs to this case. But if you operate sine outside and sine inverse inside, what is this value going to be? X will be a value between this. I hope it makes sense. Answer is going to be x only, but this x will be a value and this x will be an angle. Difference is there. Please check. You cannot have a value over here. You'll have to operating of sine. Sine will operate only on what? Angle only, right? That's why this will be angle. These are all what? Angles. Anyway, I mentioned this to already of all of you. Output of inverse trigonometric function. Output of ITF is always an angle. What is this? ITF. Output of, what is this right hand side? Outputs. Answer is always an angle. Clear? Moving on. Principle of, I just taught you this. This is for, these two are for odd cases. This one neither odd nor even. I have given you for others also. For a cot inverse, for sec inverse, I have already given that. Please check. I have already given that. Yeah. Sec inverse I have given over here. Cosec inverse I have given over here. Cot inverse I have given over here. So I have given all the three as well. Here you go. Yes. Given. Moving on to the next set of questions to solve, and then we'll wind up the class. Example. Sec square tan inverse of 2. Will sec and tan work together? No. So convert sec into tan. So sec square will come, this is an angle, right? Alpha. This is an angle beta. Sec square alpha will be what? 1 plus tan square of the same angle. Alpha, you're right. What is alpha going to be in this case? Tan inverse of 2. Over here, same way. Cosec square will be what? 1 plus cot square of same angle. Cot inverse of 3. Okay, this is 2, I guess. Yeah. Now tan of tan inverse will be what? Tan of tan inverse will be the value itself, and there is a whole square, so write the whole square, plus 1. Cot of cot inverse will be what? The value itself, we have a whole square, so write the whole square. 1 plus 4 plus 1 plus 9. 13, 14, 15. Answer is D15. D15. Please check. Next. Principal value of sine inverse of this is what? This is a PYQ. Boards. But equally important, okay? Let's solve this. Let's solve this. Sine inverse of this. Property is there, minus sine inverse of root 3 by 2. What is the answer for this? Minus pi by 3. First one is solved. Outside we have cos. Apply cos. Cos of negative value. Positive only. So 1 by. Outside we have sine inverse. So apply the sine inverse now. Answer is what? Pi by 6. 30 degrees. Sine 30 is 1 by 2. So pi by 6. Problem? No problem, sir. Moving on. Find the domain and range of this particular function. Very beautiful question and very, very easy. You'll see that. This is a Comet K and CET PYQ both. Good question. So domain will come from over here only. So basically this, we know that, has to be always more than 0. Not even equal. Do you know that why? Because this is inside the log. Log has two graphs, if you remember. Either this graph or this graph. But it is never on the left side of the y-axis. Only operates on only operates on the positive value, not even non-zero, non-negative. Only on the positive values of x. Doesn't even touch the y-axis. Only the positive value. So whatever is the inside value of log has to be always more than 0. Luckily for us in this quadratic, we can find the discriminant value. Check the discriminant value, b square. So minus 8 square. Minus 4 into a. A is 5. C is 4. Check this value. 64 minus 28. into 4, 80, minus 16, which is less than 0. When the d value is less than 0, what it means? It means imaginary root. But it actually means what? If you draw this parabola, what is this parabola? Tell me. Concave up parabola, yes or no? How come, sir? X square coefficient is positive, so concave up. Y-intercept is 4. Put x as 0, you'll get y-intercept as 4. So concave up for a parabola like this. Why like this only, sir? Because sir, check here, there's no value of x which will be on the, there's no value in the graph which will touch the x-axis. There's no point in x for which y is 0. Imagine, no real value basically. So the graph will never touch x-axis. So this means that all the points over here will be more than 0. Above the x-axis, no, there's nothing on 0 or below. So above x-axis means what? This d value more than 0 means there's no value in the graph which is going to be less than 0. So basically this property over here that you can see is valid for all x. For x belonging to any real number. You take any real number, the value of this quadratic is always more than 0 because the roots will be imaginary in nature. The graph always lies above the x-axis. The graph of this parabola lies above the x-axis means the root is always, what is it? Imaginary. So the value of the whole function will be always positive. For x belongs to all real number, check here domain. X means what? Domain. Answer is A directly. But if you want to know the range also, no problem, we'll find it. Tell me, what is the minimum value of this parabola? Can you find that? Minimum value of this parabola will be, sir, check. If I take this again, 2 branches, this is the max value and this is the minimum value. Max value will be what? Plus infinity. This parabola will go maximum up to what point? Going up, sir. So always going to plus infinity. So max value is plus infinity. What about minimum value? Minimum value is actually what? This vertex. How do you find vertex of the parabola? There's a formula, sir. F, the function value at minus b by 2a. Minus b by 2a. What is minus b by 2a, sir? Coefficient you can put over here. Minus b will be, sir, minus of minus 8 by 2 into 5. Answer is coming as 4 by 5. This is the b by 2a value. So can you find mass b by 2a, sir? Of course we can. F of 4 by 5, when you find no in this question, how do you find it? Take x square as 4 square by 25. So 60 by 25. Here also 4 by 5. When you do that, you'll get this value also as 4 by 5. Luckily in this particular case, actually, not always. Only in this case, this particular question, the b by 2a value is this. Please pay attention. First of all, I want to tell you your answer is solved. Option A is correct. But if you want to know the range also, I'm giving you the explanation. Check here. This is the value of minus b by 2a. Minus b by 2a. Put it in the function f of 4 by 5. You get in this case 4 by 5. If you're not sure, do the calculation. You'll get this value as, put the value of this x as 4 by 5. You'll get the function value also as 4 by 5. Okay, sir. Now put it here. Log of this whole thing is coming as 4 by 5 and this is with the base what? 4 by 5. Answer for this is going to be 1. Outside we have tan inverse pi by 4. Means the minimum value, so it actually becomes the maximum over here. I'll show you. This is one of the values coming at pi by 4. What about maximum value? Plus infinity. Now look at the graph. Which graph is this, sir? Actually this graph. What is shown over here? This is the graph. Because this is the graph for what? For all a between 0 to 1. This is the graph of what? Log of x with the base a, no? Yes, this is the graph of what? Log of x with the base a. And when a is between 0 and 1. What is a? Check here. A is 4 by 5. Between 0 and 1, when a is between 0 and 1, the graph is this one. So when you take this value, this particular thing as positive, infinity. So if you inside log you take plus infinity, where? with the base 4 by 5. Again, all mathematics students and teachers will tell that this is wrong. Of course it is wrong. You cannot put value of infinity at any point, okay? My understanding is, if the log, if this x value tends to plus infinity, the log value will tend to what? Check here. If you take this x value to what? To plus infinity, what is the log value going to? Down, 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 sir, which is how much? Negative infinity. The log will go to minus infinity. When you take this x value to plus infinity, the log is going to what? Minus infinity. This is not 8. This is minus infinity. So basically, if you operate tan inverse of minus infinity, this whole thing is becoming what? Log is going to minus infinity. It means this is going to be tan inverse of minus infinity. Tan inverse of minus infinity. And you know the answer for this? Minus pi by 2. So one of the operations over here, very clearly I will mention once again, is this. Another is this. Combine from here to here. Lengthy, I know, but if you want me to do it, I did that. How do you solve it? This is at infinity, so we cannot reach that. That's why we have open interval, and this is, of course, is possible to get that. That's why close interval. I told you already, no need to find it. Answer is straightforward. Option A. Check the domain, all real. Your question was done over here only, sir. But since if somebody is thinking, sir, how can we get range also? I gave the explanation. Did not understand? It's okay. Pause video, take a minute, thought, have a look, and then go back and watch it again. Okay, a very good concept how we go about this. It is all to play with the value of this. The minimum value will be at the vertex. The minimum value will be at the vertex, and the maximum will be what? Plus infinity. So max is plus infinity, minimum is at the vertex. How do you find the vertex? Max d by 2a you find out. You get 4 by 5, put in the function. Over here in quadratic you'll get also 4 by 5, luckily. And log of 4 by 5 to 4 by 5 will be 1. So tan inverse of 1 is pi by 4. This is my one boundary. Other is what? Plus infinity. When you put plus infinity inside the log, it becomes what? This is the reverse log, means for all a value between 0 and 1. So when x goes to plus infinity, fx goes to what? Minus infinity. This is minus infinity. This is minus infinity. No problem. This is minus infinity. Okay. When it goes to this, it goes to this. The graph goes to this one. When you put tan inverse of this, check here. Not sure? Check here. Tan inverse of this. I'll show you. Tan inverse of this. Where's the curve? Tan inverse here. Tan inverse of minus infinity goes to what? What is this value? Minus pi by 2. And what did I write? What did I write? Check here. What did I write actually? That only I wrote. That only I wrote. Minus pi by 2 with the open, because at infinity we cannot close it, right? We cannot close at infinity. So got the answer. Have a look one more time. A very beautiful question. One of my favorites in KCET. It would have been favorite if you had to solve. Let's say if you give another option. In this question, if this change was to plus infinity, then you have to solve the second part also. In this question, there is no other domain like all real. But if I move this 0 to plus infinity, then what are you going to do? You have to solve the second part, and then it takes time and effort and basics of learnings of the graph of log, tan inverse and quadratic. See, this is where mathematics peaks. Nothing difficult actually, but very simple and minute concepts are gelled together to get the result. And that's how questions of JEE are given, right? You must have seen that. Yeah. Okay, but again, this is CET, that's why they stopped that. This only did not write here plus infinity. Got the point? The last question, then we'll close the class. Moving on, sir. Sin inverse of A plus sin inverse of B, sin inverse of C will be 3 pi by 2. Sin inverse achieve the peak at pi by 2. And when you add these 3 pi by 2s, then only you can reach the result as 3 pi by 2. Sin inverse maximize what? Pi by 2. So you want to add 3 sin inverses and get 3 pi by 2. It means all of them have to be maximum. It means all of these are pi by 2, pi by 2, pi by 2. It means the value of A, B and C are equal as 1. Because sin inverse attains pi by 2 at the value 1. So A, B, C is 1. Now start solving this question. Doesn't matter. 1 power anything plus 1 power anything plus 1 power anything. We can find f of all of that, doesn't matter though, doesn't matter. Okay, minus 3 times of 1 power anything, again 1 power anything, 1 power anything divided by simply 1 plus 1 plus 1. Check here, 1 plus 1 plus 1, what is that? 3, minus 3 into 1 by 3, 3 is 3 cancelled, answer is 3 minus 1, 2. Option is A. Answer is A. If you're not sure, I can highlight. This is the answer and this is the option A. Clear? Clear? One second, sir. Now it's clear. Yes, we can find f of 2. F of 2 is given. We can find here f of 4 as 2 plus 2. So 2 into 2 and so on. We can do that, but no need. Right? Okay, sir. We can find f of 4 and f of 6 also possible, but not required in this particular question. Answer is A2. This is the end of your class in Masterstroke ITF. Now tell me yes or no. If you thought in the beginning that this will be a normal class, no need to study from it, a very easy chapter, are you wrong right now? It was a very interesting chapter, one of my favorite, because you learn very basic things over there and you actually use them in real life questions of examination, whether it is KCET, boards, anywhere. You will see ITF is one of the most important and most interesting concept in mathematics. Okay, this is something that I enjoy teaching, apart from integration of course, but this is something that I enjoy teaching. So I did my best to help you all understand this particular concept. Let me know what you feel about the same in the comment section, and if you have not subscribe our channel so far, that's bad. Subscribe right now and keep the notification bell turned on so don't miss any of the classes, and of course join the WhatsApp to get the class notes and more updates. That's all for the class today. I'll see you in the next class. Till then, take care. Bye bye.